Welcome. This is lesson 8.3, day 2, solving trigonometric equations by factoring. On the first day of the lesson, we talked about solving trigonometric equations like algebra equations, essentially that you isolate the trig function and then use algebraic ideals like collecting like terms or using square roots. So these two examples exemplify what we talked about on the first lesson. If I wanted to solve 2 cosine x plus 5 equals 4, I would subtract 5 and divide by 2 on both sides. And ultimately, I would get cosine of x equals negative 1/2. The range for a cosine function is negative 1 to positive 1 inclusive, so you would look in the unit circle for any values that have cosine or the x value is negative 1/2, and that occurs in two places, 2 pi over 3 and 4 pi over 3. The second example has a squared function, so ultimately you're going to be taking the square root. To solve this equation, you divided both sides by 4, and then you take the square root of each side. The square root of sine squared x is sine x, and then the square root of 3/4 is plus or minus the square root of 3 over 2, because in the context of solving an equation, you have plus or minus 2 roots. These fall within the range for x values of negative 1 to positive 1 inclusive, so there are 4 solutions in this case. There's 1 in each quadrant. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So that covers everything that we had done on the first day. Today's lesson is about factoring, solving by isolating the trigonometric function or factoring first before you do that. Before we begin factoring, we need to remind ourselves about the zero product property. The zero product property says that if you have a factored form of an equation set equal to 0, you get two factors, and they call them generically a and b. If they are set equal to 0, it implies that either a equals 0 or b equals 0. You can always say and because it can occur at the same time as well. In Algebra 1, this is what it looked like. This originally would have been 2x squared plus x equals 0. The greatest common factor was x, which is factored out. And you can see, therefore, x equals 0 and 2x plus 1 equals 0. You would finish the second equation and you would get a result of x equals negative 1/2. This second equation is a factored trig equation, where you take each factor and set equal to 0 and finish off from there. You would be able to find those angles where the cosine of x equals 0 and 2 cosine x plus 1 equals 0. For all of the examples today, we will be finding only values that fall in the unit circle between 0 and 2 pi. So number 1 is already factored, and you can see they've already got it set to tangent x minus 1 and secant x minus 1 equals 0. So the zero product property says that the tangent of x minus 1 equals 0 and the secant of x minus 1 equals 0. Let's go ahead and solve the first one to completion. If you isolate your trig function, you get tan x equals 1. And if we move over to our unit circle, we'll see that the tan x equals 1 occurs at pi over 4, right here, and 5 pi over 4, because the negative over the negative equals the positive. Second equation, we isolate the trig function and we get secant x equals 1. We're going to work with the reciprocal rather than secant, so the reciprocal of secant is cosine. And of course the reciprocal of 1 is still 1. So the cosine of x equaling 1 occurs only at quadrantals, and that occurs on the unit circle where x is 0. Example 2. Example 2 has a greatest common factor, so we're going to be taking that out. In both terms, you see a cosine x, so we're going to go ahead and factor out a cosine x from both terms. So we have cosine x, and what's left in parentheses is cosine squared of x minus 1 equals 0. So zero product property says that the cosine of x equals 0 and the cosine squared of x minus 1 equals 0. And cosine of x equaling 0 occurs at two places, pi over 2, right here, and right here, 3 pi over 2. So those are your two values for the first portion of the function. And over here, we're going to go ahead and isolate cosine squared of x, setting equal to 1. Take the square root of both sides. So the cosine of x equals plus or minus 1. That occurs on the quadrantals. That occurs at 0 and pi. So for this problem, your solutions listed in order are 0, pi over 2, pi, and 3 pi over 2. Number 3, cosine squared x plus cosine x equals 2. This is a quadratic, so I'm going to go ahead and set it equal to 0. I'm going to subtract this 2 from both sides. So I've got cosine squared x plus cosine of x minus 2 equals 0. So what we're going to do is make this look more like an algebraic equation. We're going to replace the cosine x with a variable. This is called u substitution, right? Let u equal cosine x. I'll replace cosine x back in towards the end of the problem, but now I can rewrite this problem without the trig in it. I can write this as u squared plus u minus 2 equals 0. I've replaced each cosine term with a u instead. This looks more like an algebraic equation that we would have done in Algebra 1. In fact, it's pretty much identical. So I'm going to go ahead and break this apart into two factors. So I have u and u. And then I'm looking for two factors that multiply to make a negative 2 but add up to a positive 1. And that would be a plus 2 and a minus 1. The zero product property says each of those are equal to 0. So if I solve the first factor, I'll get u equals negative 2. The second one would give me u equals 1. Now I can replace back in from my u replacement, my u substitution, and I can put cosine of x back in. So cosine of x equals negative 2. Put a negative up here instead. There we go. And the cosine of x equals 1. Now keep in mind, we do have restrictions on cosine functions, and the ratios have a range for cosines between negative 1 and positive 1. And over here, this negative 2 falls outside of the restriction. From this side of the function, we see that there are no values that you can find that have an angle with a ratio of negative 2. However, cosine of x does have a solution. So cosine of x here occurs where 1 is at 0 and pi. So those are the two solutions for this particular equation. We have 0 and pi. Let me go ahead and erase the pi value here. Just the 0 works. My mistake. If I was in class, you'd get a bonus point for that. So just the 0. Just that one. So this one had a negative 1 there. So just 0. Number 4 looks a bit more complicated because of the fact that it has a fraction involved. I can eliminate the fractions right off the bat by multiplying by the greatest common factor from the denominators. I see 2's on the bottom of these fractions. If I multiply the entire equation by 2, I can make those fractions go away. So I have 2 cosine squared theta minus 5 cosine theta minus 3 equals 0. I'm going to use u substitution, so I'm going to let u equal cosine theta. So I'm going to have 2u squared minus 5u minus 3 equals 0. If you have a coefficient of 2, it's relatively simple to factor using guess and check. 2u squared can be broken into 2u and u. And I noticed my last term is made from 3 times 1. But I also know that because the last term is negative, I need a positive and a negative. And I'm not sure which one I need. However, I need more negatives than positives to make this middle term. So I'm going to put the minus 3 in the last group and a plus 1 in the middle group, or in the first group, and I'll check to make sure that those are correct. So I have 1 times u. In FOIL, that is the inner portion, and the outer portion is negative 6u. When I add those together, I do get negative 5u, so it does match up. So it is 2u plus 1 and u minus 3. So I'm going to go ahead and solve each of these and set them equal to 0. So I have 2u plus 1 equals 0, and u minus 3 equals 0. This first one, subtract 1 divided by 2, you're going to get u equals negative 1/2. And over here, u equals 3. So now I have the cosine of theta equals negative 1/2. And that occurs at 2 positions. If you go up to your unit circle, it occurs at 2 pi over 3, right here. It also occurs at 4 pi over 3. So we have theta equals 2 pi over 3 and 4 pi over 3. Now for the second problem, or the second portion of the problem I should say, the cosine of theta equaling 3 is undefined because once again we have a restriction of negative 1 to 1 for our ratios. So this section is undefined. So your two solutions are 2 pi over 3 and 4 pi over 3. For number 5, I would like you to pause the video and try on your own. And when you're finished, you should go ahead and resume the video and check your work. So do this independently. For number 5, your two solutions are pi over 3 and 5 pi over 3. Please take note that the cosine of theta equals 2 falls outside of the range for the ratio, so it was undefined. Go ahead and pause the video and attempt number 6. When you finish, turn it back on. For number 6, the three solutions are 7 pi over 6, 3 pi over 2, and 11 pi over 6. The last problem for this lesson involves factoring by grouping. So we're going to go ahead and use u substitution, and we're going to let the u equal cotangent of beta. It'll look much less complicated. So we're going to have u cubed minus u squared minus 3u plus 3 equals 0. We're going to factor by grouping, so we're going to factor and group the first two terms together. So u cubed minus u squared. And I'm going to group these last two, negative 3u plus 3. I do want to put a plus sign in between my groups. That'll look a little bit nicer there. So plus sign. And then in parentheses, negative 3u plus 3 equals 0. First group, greatest common factor is u squared. And you're going to factor out and leave a u minus 1 in parentheses. And in the next group, we're going to have factored out a negative 3, and we'll also have a u minus 1. The common group is u minus 1. The leftovers are u squared minus 3. So we have that u minus 1 equals 0, and u squared minus 3 equals 0. U equals 1, and if we replace that with the cotangent of beta, we're not going to work with cotangent, we're going to work with tangent. So the reciprocal is tangent, and the reciprocal of 1 is 1, of course. And we have two solutions for that. If you go up and look for the division of sine divided by cosine, that's going to give you a positive 1. That occurs at pi over 4, and down here were the negatives. So 5 pi over 4 for here. So pi over 4 and 5 pi over 4. So that side generated two solutions. Now u squared minus 3 is going to end up taking a square root. This will give me solutions in all four quadrants. So we're going to add another 4 solutions to our other two answers. So we have u squared equals 3, and we take the square root of both sides. So we get that u equals plus or minus the square root of 3. So the cotangent equals plus or minus square root 3. And tangent is its reciprocal. So if tangent of beta, there we go, is plus or minus 1 over the square root of 3. Should be an equal sign in there. There we go. And we're going to rationalize that. Ultimately, it's going to be plus or minus square root 3 over 3. So we have a number of values, one in each quadrant, that fit that solution. If you look at pi over 6, and you look at its coordinates, square root of 3 over 2, 1/2, and you perform the division on that, 1/2 divided by square root of 3 over 2, that's the same as 1/2 times 2 over square root 3. Your 2's cancel. You get 1 over square root 3, which does rationalize over to square root 3 over 3. So your beta value is pi over 6. Now let's go look for all of the other reference angles that match pi over 6. So if I clear off what I already have here, there we go. And let's go up here to pi over 6. I've got reference angles in each quadrant, 7 pi over 6, 5 pi over 6, and 11 pi over 6. Those are all 30-degree reference angles, or pi over 6 reference angles. And I need pluses or minuses in all of those cases, so all 4 of those work. So we have pi over 6, 5 pi over 6, 7 pi over 6, 6, and 11 pi over 6. Now we put that all together and put those in order. So beta for this one is pi over 6 and pi over 4. Those are both in the first quadrant. Then we have 5 pi over 6 from the second quadrant. Then we have from the third quadrant two values, 7 pi over 6, 5 pi over 4. And the last quadrant is 11 pi over 6. When you complete your homework assignment, make sure that you're also using the u substitution. It is much easier to work these problems when they're written in an algebraic format.